let's dive right into this explainer. We talk so much about the space race, mapping the surfaces of the moon and Mars. But here is a wild thought. A staggering 95% of our own global deep ocean is just entirely unexplored. So today, we are looking at India's absolutely massive deep ocean mission. This is an unprecedented initiative to go thousands of meters below the surface. We're talking extreme engineering, the hunt for incredible mineral wealth, and a very real race to secure high-tech sovereignty. To really wrap our heads around the sheer scale of what we're looking at, we have to start with the financial commitment. The Indian government is putting down an estimated 4,077 crore rupees over 5 years for this. And this isn't just your standard science grant, right? It's a full-on mission mode project spearheaded by the Ministry of Earth Sciences. It represents a massive foundational push to harness what they're calling the blue economy, essentially turning the ocean into a major engine for sustainable national growth. We are going to structure this explainer just like a physical dive. First, the race for the abyss. 2, the $11 billion treasure. 3, engineering the Matsya 6000. 4, mining the ocean floor. And finally, 5, India's deep sea future. Let's get into it. All right, starting right at the surface with Section 1, the race for the abyss. Now, this is really fascinating. Right now, the capability to send humans deep underwater is locked down by a highly exclusive 5-nation club. We're talking about the United States, Russia, China, Japan, and France. That's it. And India is pushing incredibly hard to become the 6th member. Because when you think about global maritime dominance, having deep ocean capabilities is just as critical and honestly probably just as complex as launching satellites into orbit. This whole mission is way more than just a cool science experiment. It is a massive strategic push for maritime domain awareness and a cornerstone of that blue economy vision we mentioned. Through these initiatives, the goal is to help India hit a target of over 100 billion rupees through the sustainable use of its ocean resources. It's really about pairing deep-sea exploration with technological self-reliance, all while keeping a very close eye on the vast Indian Ocean region. Okay. As we start our descent into the mid-water, we have to ask ourselves, what exactly is driving this high-stakes underwater gold rush? Let's look at Section 2, the $11 billion treasure. Here is the crucial point. Scattered across a massive 75,000 square kilometer site in the central Indian Ocean Basin, which was specifically allotted to India by the UN's International Seabed Authority, are these bizarre metallic rocks called polymetallic nodules. Honestly, just picture the most expensive potatoes on Earth sitting quietly on the abyssal plains, roughly 4,000 to 6,000 meters deep. These little potato-shaped rocks are literally the key to the future. When you break down the chemistry of these nodules, you find an absolute treasure trove. We are talking manganese, nickel, copper, and cobalt. India has uniformly sampled this area and estimates there are about 366 million metric tons of these nodules present. And these aren't just random metals. They are the absolutely critical backbone for electric vehicle batteries, aerospace engineering, jet engines, and high-tech components. Which brings us to the undeniable economic reality. The estimated value of the metals sitting inside India's allocated exploration zone is a staggering 110 billion US dollars. No way around it, that's a game changer. As our land-based resources for these strategic metals dry up rapidly because of insane global demand, the deep sea has completely shifted from being a scientific curiosity to a completely vital resource reservoir. Just think about this staggering statistic for a second. If India can successfully and sustainably harvest just 10% of this polymetallic nodule reserve, the country could theoretically meet its specific energy and technological material requirements for the next 100 years. 100 years! It perfectly highlights exactly why this deep-sea treasure is being so fiercely pursued. The stakes, quite literally, do not get any higher than that. All right, descending even further past the 1,000-meter mark, we need to look at the incredible vessel that's going to actually take human beings down into that crushing darkness. Welcome to Section 3, Engineering the Matsya 6000. Meet the Matsya 6000. Named after the fish incarnation of Lord Vishnu, this is a 4th-generation, completely indigenous manned submersible designed by the National Institute of Ocean Technology, or NIOT. under the Samudrayaan mission, this incredible piece of machinery will carry 3 aquanauts a full 6,000 meters deep. It's got an operational endurance of 12 hours, but crucially, it has a 96-hour emergency survival capacity. They've packed it with advanced oxygen regulation and scrubbers that chemically strip deadly carbon dioxide right out of the air, ensuring the crew can survive for 96 hours if things go wrong. And things can definitely go wrong because down at those depths, the ocean is literally trying to crush you with 600 times the atmospheric pressure you feel right now at the surface. That is up to 720 bar. To survive that insane environment, the sub relies on a specialized 2.1-meter diameter pressure hull made entirely of a high-strength, corrosion-resistant titanium alloy, which they developed alongside the Indian Space Research Organization. Because of this incredibly claustrophobic, hyper-precise environment, that titanium sphere has to be completely flawless. Even a microscopic imperfection means instant disaster. Get this, a deviation of just 0.2 millimeters in the hull's thickness could lead to a catastrophic structural failure under all that weight. 0.2 millimeters? It absolutely showcases the extreme precision required for deep-sea engineering. And the timeline for this really shows how globalized and complex the engineering is. While calm water functionality trials with 3 humans were successfully demonstrated in January and February of 2025, the crucial 500-meter shallow water dive has hit a delay. Right now, they're waiting for this specialized synthetic foam to arrive from a designated firm in Europe by May 2026. This foam is vital. It's a high-tech material that won't crush under the deep-sea pressure and provides essential buoyancy, but they had to wait for a new batch after an earlier manufacturing defect. It just proves that this kind of extreme engineering is a deeply interconnected global effort. Okay, we have finally hit the pitch-black ocean floor, where they are actually testing the extraction tech. Section 4, Mining the Ocean Floor. Back in 2021, an incredibly grueling 1,700 nautical mile voyage on the research vessel ORV Sagar led to the world's deepest underwater trials for a mining machine. India actually successfully sent an automated crawler down to an astonishing 5,270 meters in the central Indian Ocean to test its mobility and power systems. Just wrap your head around that depth for a second. What they were testing was the Varha Integrated Mining System. This thing is a massive 8-ton crawler machine purpose-built to scoop up that $110 billion treasure. The process itself is fascinating. It moves along the seabed, tethered to a mothership, collects and crushes those polymetallic nodules, and eventually, in a later stage of development, it's going to pump a thick slurry of those crushed rocks and seawater miles straight up to the surface ship using massive, high-pressure industrial pumps. Ascending all the way from the depths back up to the surface, let's look at the immense strategic implications of this entire operation. Section 5, India's Deep Sea Future. Beyond just the raw materials, this mission is fundamentally about high-tech sovereignty. India's data transmission capacity is expected to quadruple by 2025, with new undersea cable landings, so securing those submarine telecom cables is absolutely crucial for the digital economy. On top of that, all these technological spin-offs in autonomous underwater vehicles and deep-sea robotics, they feed directly into defense and space applications, giving India serious maritime domain awareness in the Indian Ocean region right when regional competition is heating up. It leaves us with a truly provocative reality. The deep sea is no longer just some scientific curiosity. It is for sure the ultimate geopolitical battleground of our future. As India pioneers manned dives and automated mining at 6,000 meters, it isn't just scooping up metals. It is securing a seat at the table to shape the global governance rules of the deep ocean. Who will ultimately control this final frontier? Well, that's the billion-dollar question we're going to have to keep watching. Thanks for joining me on this explainer, and I will see you on the next deep dive.